Now next electrical device is a capacitor. A capacitor is an electrical device which causes a delay in the flow of current or in the flow of charge. Now how this delay is caused? Because it has ability to store charge in it. Okay, the symbol of capacitor is like this whenever you are representing a capacitor. This is the symbol of capacitor. Now in between this capacitor, we are going to fill up some material such that whenever the charge flows or when the current flows through this part, these materials, they will be able to absorb that charge, and it means they will not be allowed to flow for a certain period of time. That is going to depend upon the capacity of or capacitance of what kind of material, how much and how much of that material is being stored. Once that particular capacitance is reached, then the current starts flowing. So because these materials have ability to store charge in them, they cause delay in the flow of charge or in the flow of current. It means for a certain amount of time, the current will be stopped, and after that, the charge will start flowing. Okay, you must have seen those self-timered cameras.
Yeah.
So in between the circuit, if you are having a capacitor, then for a certain amount of time, okay, the current will stop flowing, and once that level of storage of charge is reached, it means that much time delay is reached, then the current is allowed to flow. Okay, so for example, in self-timer cameras, you have certain time like 5 seconds, 10 seconds. You just press the switch. It means at that time you have switched on the current. But that capacitor which is there, it holds that charge for that much amount of time. And after that capacitance is reached, then the current is allowed to flow. Okay, and then the flash happens and whatever the circuit is there, photograph or whatever is taken, that occurs. Okay, so this is the basic of the capacitor, that is the cause in delay that is caused due to the storage of charge. Okay, the next part that we are going to take up over here is logic gates. Okay, basically the logic gate is such a kind of a device where there will be two inputs will be there. Okay, then there is going to be some kind of processor. This processor, we call it a transducer. It is going to process that signal, and depending upon what it is allowed to do, okay, the signal will be there or it is not going to be there. So on the basis of this, the logic gates are going to function. We are going to have different types of logic gates, and depending upon what input and output we are going to get, we are going to prepare a table for this. These tables that are prepared, we will call them truth tables. Okay. Now the first of these gates I am considering, which is the simplest of all. In this, there is only one input and there is only one output. I am first drawing the symbol of this gate. I have drawn first the symbol of this gate. Here, if the current is there, there will be no current. And other way around, if the current is not over here, then the current starts flowing. It means it just makes the signals reverse. This kind of a gate is known as a NOT gate. Okay, it just reverses that digital signal. So the truth table for this, there is only one input, there is only one output. In input, if the current is there, so for that I will write 1, there will be no current. If there is no input, in that case the output is going to be there. So 1 will be turned into 0 and 0 will be turned into 1. This is going to be AND gate. Okay, AND means simply the word itself indicates this and this. It means there will be two inputs and there is going to be one output. First I'll draw the symbol of AND gate. This is the symbol of AND gate. A and B are the input signals and C is your output. Okay, so there will be two input signals and there will be one output available. Okay, now on the basis of what signals we are having on A and B and what is the output that we are going to get, we are going to prepare the truth table. So first I'm going to write what is the input. There are two inputs, one is A and second one is B, and there is one output which is going to be C. We are going to have four possibilities. Both of them have current. A has current, B doesn't have current. A has no current, B has current, and A and B both do not have current. Okay, so on the basis of this we are going to get the output at C. Now as I've said, the name of the gate is AND gate. It means A and B both should have current, then only we are going to get the output at C. For rest all, we are not going to get any output. So this is the truth table for AND gate. The next gate that we are taking is opposite of this. See, we just now did AND gate. Before that we had done NOT gate. NOT gate just makes everything reverse. I'm just going to combine both of these and I'm going to make this gate as NAND gate. It means it is just the opposite of AND gate, or you can say it is combination of AND gate and NOT gate. Alright, so first I'm going to draw the symbol for this. This is going to be, this is your AND gate. A and B are your inputs. C is your output, but we are going to make a small circle over here. This circle is because of NOT, and the other part is the AND gate. So the combination of this is going to become NAND gate. The truth table is going to be just exactly opposite of what we have done over here. Okay, so wherever here 1 is there, that is going to become 0. Wherever 0 is there, that is going to become 1. Okay, so we'll just prepare the truth table for this. That is, first your input is there, then your output is there. A and B are your inputs, C is your output. So 1 1 1 0 0 1 0 0. Okay, we'll just make reverse of this. This is going to become 0, the rest all part is going to become 1. This is the truth table for NAND gate. Okay, we have two more types of gates. The next one is OR gate. Okay, the OR gate is represented like this. There is slight difference. These are the inputs. This is your output. Okay, the only difference between AND gate and OR gate is this line which is there, that is curved in case of OR gate. In case of AND gate, this line is a straight line. Okay. Now, as the word OR suggests, it means either this or this. If any one of these having signal 1, then the output is going to be 1. Okay, so on the basis of this, we are going to prepare the truth table. First, the input is there. So 1 1 0 1 1 0 0 0. Okay, here both of them are 1, so we are going to get the output. Here B is 1, so we are going to get the output. A is 1, we are going to get the output. Here both of them, there is no input, so here we are not going to get any output. This is going to be the truth table for OR gate. The last of these gates that is there. Now we are going to combine the OR gate and NOT gate. So this is going to become NOR gate. So it's the combination of NOT gate and OR gate. First of all, the symbol is very similar except that NOT part which comes. These are your input terminals. This is the NOT part, and this is your output terminal. We are going to make the truth table of this. So first the input and then the output. Okay, it's going to be exactly reverse of OR gate. This will be 1, rest all will be 0. Okay, this is the truth table for NOR gate.